Okay, this is a cost rule question. It doesn't look like it's a cost rule question, but it is. A cost rule question typically would look like something like this, where you've got a triangle, you've got a side, maybe 10, another side, 12, you have an angle, maybe 45 degrees, and you had to find this x. So you've got a side, an included angle, and you normally are to find the other side, the side opposite the angle. But what we've got here is you can still use the cost rule for it. So the for this, the cost rule says if this was your A, then this would be your angle A, and this would be side B, and this would be side C. So by the cost rule, say A squared equals B squared plus C squared minus 2BC cos A, and then we'll just fill this in and we can get rid of that diagram. So if we fill it in, you'd have 15 squared is equal to 12 squared. I'll do my x first, just make it a wee bit nicer looking. I'll do my 15 squared equals x squared plus 12 squared minus 2 times, and we'll say our 12 times our x times our cos of 81. Now, it's not going to be very pretty, but it's going to work still. We're going to bring everything over to one side. You're now going to have x squared plus the 12 squared minus the 15 squared, and then if we'll just write here 2 times minus 2 times the 12 times the cos 81, and that's being multiplied by the x. So what we've actually got is going to have here is a quadratic. So we've got 0 is equal to x squared, and then I'm going to do the minus 2 times the 12 times the cos of 81, and I'm going to do this to 5 dp's. So that got me minus 3.75443, that was x. And then what I've got is 12 squared minus 15 squared, which equals just minus 81. So you've got a quadratic equation. So remember quadratic equations, if you have 0 equals ax squared plus bx plus c, that means you could solve that by saying x is equal to minus b plus or minus the square root of b squared minus 4ac, square root of that, all divided by 2a. So you could jump straight into it now. So here, I'm just going to write down what my values are. My a, it's nice and easy, it's just 1. My b, not so easy, it's minus 3.75443. And I would work to 5 dp's on that, just to maintain some accuracy. And then we can fire that into our equation. So x is going to be equal to minus b then, would be positive 3.75443 plus or minus the square root of 3.75443 squared minus 4 times my a, which is 1, times my c, which is minus 81, all divided by 2a, which is just going to be 2. Okay, give me a second here when I work this out. Fire this into my calculator and work this out. Okay, so do this just on your calculator. I don't need that to write this down. We're just going to get our 2x values. We're going to do the minus one. So use your fraction button and the wee square over the square, and you'll have 3.75443. And we'll do the minus one, minus square root of, and then it was 3. That really was a minus. Well, it might be, that should be a minus. Not that it matters because the bracket sorts it out. So you're squaring minus of 3.75443. That's squared, and then minus 4 times 1, and then times our minus 81. That's all inside the square root. Go down to the bottom line. That was all over 2. And when I press equals, I got minus 7.316. I'm not too sure what degree of accuracy I needed to go to here. I'll do another 2 dp's here, and then the other one. So just go back up to onto your calculator and go up and change that minus that's in front of the square root sign. Change it to a plus, and I'm really hoping I get 11 here because I know that's the answer, and I do. 11. It was 11.0709. And I think we'll give our answers to 2 dp's. So the answer, let's have a think about it. It was a length, so you're not going to have a negative length, so my answer is just x is equal to 11.07, and that was to 2 dp's. I can't remember what the units were. We did have units, centimeters, so 11.07 centimeters to 2 dp. So it's a pretty difficult question, but you can use the cost rule then. If you've got you've all two sides, an unknown side, and you've got one of your angles by doing that method. So it's a bit unusual, but you can do it that way.